Section R5 is where we're going to be. Section R5, and this is rational expressions. Fractions. Okay, so rational expressions, fractions, is what we're dealing with in this thing. So the instructions that we're going to start with, the first set, are going to tell us to simplify and state the domain. Simplify and state the domain. Okay, so there's an important part here about stating the domain that they don't tell us. And one of those things that we learned in 110 was that when you're finding the domain, there are two red flags that you look for. Those red flags are an x in a denominator of a fraction, which is what we're going to see here, or an x inside of a square root. Okay, so x's in the denominator of the fraction are going to be the keys to the domain. Okay, and you need to find the domain. So domain must be done before you simplify. Okay. Domain is done before you simplify. So that's going to be an important part. Okay. So let's get our first example. And I'm going to be nice to you on this first one, and it's already going to be in factored form. So what this is going to do, this lesson is going to do, it's going to combine together the things that we did in labs today with the stuff that we kind of already know. And it's going to put letters in there instead of just numbers. So it's going to we're going to have to do some factoring. We're going to have to do some solving. We're going to have to do a lot of things that we did in 100. Just going to come back up in this first lesson. The factoring is going to be the biggest tool that we need. But then we're going to have to adapt some of the skills that we worked on with fractions into this stuff. Okay, so the numerator for this problem is x minus 7 times x minus 1. The denominator of this problem is x minus 1 times x plus 3. So before we simplify that, we want to find the domain. So to find the domain, we're going to take the denominator, x minus 1 and x plus 3. So we're setting the denominator equal to 0. So to find the domain on any of these fraction problems, set the denominator equal to 0. That's how you find the domain. Okay. Since this one is already factored, I don't have to do that X method thing or anything like that. It's already been factored for me, so I don't have to do that on this one. I'm ready to solve it. So back in 100, when we were doing these kind of problems, when it was factored and it was set equal to 0, you took each factor and set that factor equal to 0. So I'm going to take the x minus 1 factor, set it equal to 0. I'm going to take x plus 3, set it equal to 0. And I'm going to solve each of those and get x by itself. So add 1, x equals 1, subtract 3, x equals negative 3. Those are the numbers that x is not allowed to be. Okay, so the domain for this, so this is where we're writing out the actual domain. In set notation, all x's, as long as x does not equal negative 3 or positive 1. Little curly braces around that. That is what's called set notation. Set notation. That's the one with the curly braces. and the x's and all that in there. Okay. Interval notation is the one with the parentheses, the brackets, the u's, the infinities, and all that stuff in it. So the interval notation for that, we would start at negative infinity. We'd go to -3. We skip -3. We go to 1. We skip 1. And then we go to infinity. That is the interval notation for that. Need to be able to write it both ways, because how they're going to ask for it on the final, they do it two different ways. I mean, they really bounce back and forth between them. So be able to write the domain in either set notation or interval notation. So you're taking the denominator and set it equal to 0, and then just solving the equation. Okay? This one's already factored, so that makes simplifying really easy. After you found the domain, that's when you can simplify. So when I look at this one, the thing that we had done in the lab was that we had looked at the factors of the numbers and canceled out the matching numbers, right? In this case, the factors are the sets of parentheses. So you've got an x minus 7 and an x minus 1 up top. That's like having a 3 and a 5 up top. On the bottom, you got an x minus 1 and an x plus 3. That's like having a 5 and a 7 on the bottom. Okay? The things that are the same can cancel out. So the x minus 1s are exactly the same. So that whole factor, x minus 1, cancels out that factor x minus 1. They cancel each other out. And the simplified form is just going to be x minus 7 over x plus 3. That is our simplified version of that fraction. The domain has to be done before that, because if you do it afterwards, you're going to lose part of the domain. Because you look at the denominator of what's simplified, everything's not there that was there originally. Okay, so domain's got to be done before you simplify. So this one was nice. It was already in factored form. Let's get one that's not in factored form. So we got to do the factoring. So this is where we're putting together the stuff that we did in labs. So we have x squared minus 6x plus 5 over x squared minus 25. So before I do anything, I'm going to take the denominator and set it equal to 0 to find the domain. X squared minus 25 equals 0. Now, when you go to find that, when you do that, the best way to solve those is by factoring. The reason that's the best way is it's going to save you a step on the simplifying. So if you can factor the x squared minus 25, you can use that factoring again when you go to simplify. So that's why you want to solve by factoring if possible. Okay, so in this case we can. X squared minus 25, how does that factor? Very good, it's a difference of squares. X plus 5, x minus 5. And then we're going to set those equal to 0. So x is equal to -5, x is equal to +5. So the domain in set notation is all x's as long as x does not equal plus or minus 5. And it's absolutely okay for you to write it that way. If you wanted to write -5, comma, +5, you could do that too. But the plus or minus in front is absolutely fine. Now, what is that in interval notation? A little bit harder to do. There you go. So negative infinity up to the -5, u -5 to +5, u 5 to infinity. parentheses all the way through there. There is our domain in set and interval notation. The good news is because I use factoring to solve that denominator, I've already got the denominator factored as x plus 5, x minus 5. Now I just need to factor the numerators, see if I can get anything to cancel out. Okay. So multiply to be 5 and add to be negative 6. 5 times 1 is 5. 5 plus 1 is positive 6. Yeah, get your sign. The signs are important. So negative 5, negative 1. So that's going to be x minus 5 and x minus 1. What cancels out here? Yeah, this x minus 5 cancels that x minus 5. That's all that cancels. You can't cancel part of a factor. So part of a factor, what I mean is you can't cancel this x and the x minus 1 with that x and the x plus 5. It's either all of the x minus 1 or none of it. It's got to be a whole factor. You can't just do part of it. Okay, so the simplified version would be x minus 1 over x plus 5. There's our simplified fraction. When do you find domain? At the very beginning. That's the key thing you got to remember. Domain is done before you do anything else. Domain is done before you do anything else. Okay? So let's practice the simplifying part, because I think that's the hardest part of this. Let's just forget doing the domain for right now. Let's work on the simplifying part mainly here. So just the instructions are just going to be simplify on these next few problems here. Example C, let's take 12x squared minus 30x over 4x squared minus 25. Let's see if we can simplify that. So not worried about finding the domain on this one. We're just trying to simplify it. So we're just going to factor top and bottom. So how does the top factor here? Top wouldn't be a difference of squares because 30 isn't a square number and neither is 12. So it can't be a difference of squares on the top. 6 is a bigger number that goes into 12 and 30 than 2 is. So 6 is better. What else do they have in common besides 6? X, yeah. And that's going to leave us 2x minus 5 in the parentheses. Now the bottom part, you got two terms. You got a 4x squared and a minus 25. That is a difference of squares because 4 is a square number and 25 is a square number. So that's really 2x squared minus 5 squared. So the factors would be 2x plus 5 and 2x minus 5. So we've got the factored form of that, and now we cancel out the matching factor, if there is one, and there is on this one, 2x minus 5. So my simplified version is 6x over 2x plus 5. And again, you can't cancel the 2x with the 6x because this 2x is tied to the plus 5. It's got to be the whole thing or none of it. Okay. Questions about that one? So all of these ways of factoring that we went over in the first lab tonight, they're going to come back up in everything we do here. We just got to be ready for any of it. X squared minus 8x plus 16 over negative 2x squared plus 8x. So let's factor that. How does the top factor? What method? The tree or the X thing, whichever way you want to talk about it, that's fine. So multiplying to be 16 and adding to be -8. -4 and -4. So my factors are x minus 4 and x minus 4. In these problems, I would probably not write it as x minus 4 squared. That way I've got all my factors separated out. Once I've simplified, then if there are two of them there, then I'd write it as that squared. But at this point, I'm going to leave them separated. Now, the denominator is a little trickier on this one. What would you factor out of the denominator on this one to make things cancel out? Yeah, that negative needs to come out so that this will turn into an x minus 4 out of that. So that anytime your leading coefficient or your number in the front of a problem is a negative, when you pull that GCF out, if you'll pull that negative with it, that will help things a lot. Usually is the kind of the trick of the trade there. So pull out a -2x, that's going to leave me x minus 4, and now we can get a cancellation happening. How many x minus 4s cancel? One on top cancels out one on the bottom. Okay, so make sure you don't double cancel. It's a 1-to-1 cancellation. So that's going to give us x minus 4 on the top, -2x on the bottom, and there's our simplified version on example D. Not too bad so far. It's not terrible. It's just a little more fun as we go along. Let's try one on your own here. So try one that's a little bit more difficult. 2x squared plus 7x minus 4 over 5x squared plus 20x. See if you can factor that and get something to cancel out. Pull away from the wall. I'm going to do the denominator first because it's easy. Than the top. Top's a little bit more difficult because you got a number in the front of the x squared. Hopefully you're getting an x plus 4 and a 2x minus 1 when you factor the numerator there. So multiply 2 times -4, that's the -8 on the top. Got to add to be 7 in the bottom, so that's +8 and -1. I replaced that in the middle and grouped 2x squared and 8x. GCF is 2. -1 on the next pair leaves an x plus 4 in both parentheses. So that's the x plus 4 up top. The 2x plus 1 is the other stuff. And then we canceling. Yeah, x plus 4s go bye-bye. So we got 2x minus 1 over 5x. You've simplified that straightforward problem there. So this is kind of the combination of the factoring that we had done on lab 1 with the first page of lab 2 where you just simplified the fractions. Okay, so that's what we're putting together there. for these first 6 examples. Okay. Factoring, big part of that. Understanding how to simplify fractions, a big part of that. Okay. Now let's put together the factoring from lab 1 with the multiplication that we did on page 2 of lab 2. Lab 2, yeah. Okay, so first, let's just remember if we're multiplying 6 over 7 times 21 over 30. How did we do that? Well, we looked at the factorization of 6. It was 2 times 3. 7 was just 7 times 1, so it was prime. What is the factorization for 21? 7 times 3. I'm going to write it 3 times 7 because I just got to. And then the 30, a little bit more difficult. 2 times 3 times 5. That would be, 2, a 3, and a 5. Okay, so that's what we did in the lab. Okay, and the idea is that you factor each part. Okay, so and then you cancel matching factors vertically and diagonally. Okay, so this is what we did in the lab with numbers only. Okay, so I'm going to cancel out this 2, cancels that 2. This 3 cancels that 3. This 7 cancels that 7. And all of it got is a 3/5 left, 3 over 5. Okay, we did that in the lab. So nothing is different about that than what we did in the lab. But the idea is that you're going to factor everything that can be factored in the problem, top and bottom of each fraction. All right, so let's look at one that's got some letters mixed in there. So 6x to the third over 7 times 28 9x squared. Okay. So we're going to do the same thing, but we got x's in there. Okay, so it's a very similar problem. Got some of the same numbers, some different numbers. So the first fraction, the 6, is still 2 times 3, but what does x cubed mean? X times x times x. Good. And then on the bottom, we still got the 7. Okay, the next fraction, we got 28. And 4 breaks down into 2 times 2 times 7. And then on the bottom, 9 is 3 times 3. And then x squared is x times x. Okay? Letters involved, no addition or no subtraction in the parts there. We can do it like this. Same rule. Cancel vertically, cancel diagonally. Okay? So vertically, don't see anything vertically, but diagonally, I have a 3 canceling a 3. I have a 7 canceling a 7. And then I have this x canceling that x, this x canceling that x. So what's left? I got 2, an x, 2, and 2. That's 8x, right? Over the 3 is the only thing left on the bottom. It's just a 3. Boom. Another way of doing that would be subtracting the exponents on the variables. So 3 minus 2 is 1. The biggest set was on the top, so the answer would go on the top. So you could subtract the exponents and do that as well. Both ways work. To me, this seems to be the most logical way to go according to how we had been doing it. So let's do another one of those. So let's say 4y squared over 18 times 27 over 8y to the third. I don't know why I put so much space between my 8 and my y. Let's put them back together there. So see if you can simplify that one using those same ideas, whether you subtract your exponents on the variables or cancel out, write them out and cancel out. I'm just writing it out as all of the factors, all the prime factors. Which to me seems to be the simplest way to do it. And then you cancel vertically, you cancel diagonally. So vertically, I got a 2 and a 2. And that's all I have vertically. Diagonally, I got a 2 and a 2, a 3 and a 3, another set of 3s, and then how many Y's? 2, 1, 2 on top, 1, 2 on the bottom. 3 over 4, and there's a Y still down there too. A Y down there with the 4. 2. Yeah, that's the right simplification. Okay. All right. So numbers with letters and exponents. That kind of idea. Okay. Those are probably the next easiest thing. All right. Let's get some factoring happening again. All right, so here we have, and I'm gonna go ahead and put that x plus 5 in parentheses, even though you don't have to, but I like putting all my little factors in parentheses. Just makes it feel like they're all closed up and ready to do something with. Okay. Now, here we have a fraction times a fraction. So it's the same rules. You want to think about the factored form of everything. Okay. The good news is on example I, everything's already factored for us. So we don't have to do anything as far as factoring goes. Once it's factored, then we can take that and simplify. And the only way to simplify on the multiplication is cancel up and down vertically or diagonally. That's the only ways. Okay. So vertically, I've got an x minus 3 canceling an x minus 3. Yeah, and diagonally, I've got an x plus 4 and an x plus 4 canceling each other out. So all that's left is this x plus 5 on the top and that x minus 1 on the bottom. And you've simplified a multiplication problem. So this is combining together the factoring with the second page of Lab 2. So the factoring from Lab 1 with the second page of Lab 2. Okay, so let's get one where we have to do the factoring for it. Okay, so example J, x squared plus 7x plus 10 over, let's just do x plus 2 on the bottom, times x squared plus 6x plus 8 over x squared minus 25. So a lot of factoring to do on this one. So I'm going to try to factor everything that can be. Okay, so you've got to factor the numerator over here, the numerator on the second fraction and the denominator on the second fraction. So don't have to factor x plus 2 because it won't factor. There's nothing it'll break down to. So we're just going to try to factor all of these one piece at a time, as Johnny Cash said. I factored it one piece at a time, and it didn't cost me a dime. Stressed me out, but I made it through anyhow. All right. So what multiplies to be 10 and adds to be 7? 5 and 2. That's good news. So that's going to be x plus 5, x plus 2, and then the bottom has the x plus 2 that nothing happens to. Okay, so there's our first fraction factored. Second fraction, let's factor it. So we're multiplying to be 8, adding to be 6. 2 and 4, so that's going to be x plus 2, x plus 4. Okay, the denominator of that fraction. Yeah, it's a difference of squares. We've seen that a lot. X plus 5, x minus 5. Whichever way you want to write that, doesn't matter. Now we've got everybody factored as far as they will, and you can start canceling vertically and diagonally. That's the only ways to cancel, is vertically and diagonally. So I see a vertical happening there. I've got that x plus 2 on top and x plus 2 on the bottom. And then I have diagonally, I have an x plus 5 and an x plus 5. Since I used up that x plus 2 here vertically, I can't cancel this one on the other fraction because I only get a 1-to-1 cancellation. Can't use it more than once. It burns it up, okay? So that's going to leave me x plus 2 times x plus 4 over x minus 5. Or they may write it out multiplied. I usually leave them factored when I'm doing it. Or when I'm writing the test and everything, but I don't know how the final is going to do that. So I'm gonna go ahead and multiply that back together and get x squared plus 6x plus 8 over x minus 5. Both are correct. And they both say the same things, but one is in the factored form, one is in the multiplied out form. Like I said, I don't know which way they'll put it on the final. I've seen it both ways. I like this way better, but some teachers like this way better. It doesn't matter. It's the same thing, though. Okay? All right. Do another. 4x squared plus 3x minus 10. 2x squared plus 3x minus 2 times 2x minus 1 over x plus 4. I'll be nice and not have to make you factor the second fraction. The first section is definitely the longest section of the night. I promise you that. It has got the most examples and the most stuff in it. The second section is I think much easier, even though it deals with graphs a little bit. All right, see if you can get this factored. Got to have that number in the front of x squared, makes this a little bit more difficult. So see if you can get this factored. It's a right angle right there. Look at there. Pretty nice. We did that. So multiply to be negative 40, add to be 3. 8 and negative 5. So I got to do the grouping thing here. Four x plus 2, negative 5, x plus 2. So my factors are x plus 2 and 4x minus 5. So there's the numerator of the first fraction. I'm just going to go ahead and copy the second fraction because I know it doesn't factor any. So factoring on the denominator of that fraction. Multiply to be -4 and add to be +3. 4 and -1. Okay, so the 2x squared plus 4x minus 1x minus 2. Grouping that. 2x, x plus 2, -1, x plus 2. So x plus 2 and 2x minus 1. So over here, I've got the factored form of everything. Okay, so I factored this using my factoring skills that I have. And now I'm doing the new thing, which is the simplifying of a multiplication problem with fractions. So what's going to cancel? X plus 2 cancels the x plus 2 vertically, and then diagonally I get a 2x minus 1 canceling each other. So it's funner when you make the little laser sounds. Anything to make the day pass. 4x minus 5 over x plus 4. And you got to simplify. Questions about multiplying. About through that. Multiplying these fractions. Key is being able to factor. If you struggle with factoring, that's what you got to practice on. Okay. If you're struggling with that, Khan Academy, if anybody's ever used Khan Academy, it is a wonderful website that has like free practice stuff on there. So if you struggle with factoring, it's got instructional videos, it's got practice problems, and it'll tell you whether you got it right or wrong the whole way through. So Khan Academy is a really good resource for you to practice factoring, get better at it if you're struggling with that, because that's going to be the key to this. If you can't factor, kind of on the outs on this, it's going to hurt you. Okay. All right. After we multiply in lab 2, we did division. Okay. So let's do x squared minus 4 over x cubed minus 8 divided by 9x squared minus 1 over x squared plus 6x plus 8. All right. So if we're going to divide fractions, what do? Keep, change, flip. So if I'm looking at my problem on Canvas or on my textbook and it's telling me to do the division, when I go to write it down, I'm just going to rewrite it as x squared minus 4 over x cubed minus 8 times x squared plus 6x plus 8 over 9x squared minus 1. I'm just going to write it like that from the get-go because that's what I'm doing. And then I'm going to factor everybody. So x squared minus 4, how does that factor? Very good. So you're good at the differences of squares. What about x cubed minus 8? Difference of cubes. Oh, gosh. Those are the hard ones. Okay, so difference of cubes. So we got to think what cubed is 8? Yeah, it's 2 times 2 times 2. So the difference of cubes, you got the x minus 2 in the short factor, and then the long factor, you got x squared plus 2x plus 4. And that comes from taking that 2. So you took the x out, so that left you an x squared. Then the middle term, you're multiplying the 2 times the x. And then you swap the sign in the middle. So if it's a difference of cubes, it's a plus in the long one. And then the last piece is you square the 2. That's where the 4 comes from, 2 squared out of that. So that is a difference of cubes. We don't get to factor those very often. So if you're struggling with those, I understand. They just don't come up enough for us to practice them. So I thought, let's throw one in here because we need to practice that if we're going to have to do it. Now, x squared plus 6x plus 8. I think we factored that once already today. Multiply to be 8, add to be 6. 4 and 2, so that's going to be x plus 4, x plus 2. And then 9x squared minus 1. Yeah. All right. Now, let's see if we can get some stuff to cancel. Not much, but there's a little bit. Okay. So we got a little bit of cancellation happening here. We have an x plus, or excuse me, an x minus 2 on the top and an x minus 2 on the bottom. So that's going to cancel out. Nope, it's side to side, not diagonally. So be careful of that. That's a very common thing. That would make it happen there. All right, so we got x plus 2, we got x plus 4, we got x plus 2 on the top. Oh, that's ugly. We're going to leave this one in factored form because I don't want to multiply this out. We'll just make it look a little better. And then on the bottom, we've got the x squared plus 2x plus 4. That doesn't factor anymore ever. If it came from a sum or a difference of cubes, the long factor never goes any further. It's always got complex roots, so it never goes any further. And then we have 3x minus 1, 3x plus 1. How could I make the top look just a shade bit better? Yeah, I could write that as x plus 2 squared. I probably wouldn't do that when I'm talking about factored form. If I were talking about the domain, then yeah, probably I could do that. But if I'm talking about factors, I probably wouldn't. You're probably not going to see them do that. You would like see them write that as x plus 2 squared, though. I'm not saying there isn't an author out there somewhere that would do that, but it's not likely. I haven't met one yet that does that. So there's us a division problem. We flipped it, we factored it, we simplified as much as we could. Okay. Let's do one more division problem, and then we'll add and subtract. 5x squared minus 16x plus 3 over x squared plus x minus 12 divided by 30x squared minus 6x over 2x cubed plus 8x squared. All right, so division problem. See if you can get it flipped around. So keep, change, flip, and then factor it all. See if you can get some stuff to cancel. That's the key. Is the factoring's the thing. If you're struggling with the factoring, you're just going to struggle with this. You've got to work on it, and the more practice we get with it, the better we're going to get at it. It's kind of like doing the bottle flip thing. The more you practice it, the better you get at it. I'm going to do a little factoring as I keep, change, flip. Oop, I didn't flip it. Check your factoring there after you've keep change flip, and then check your factoring. A lot of stuff canceling on this one. Lots of stuff. It's kind we like. When a lot of stuff cancels out, that means we're doing some good with our simplifying. So I end up with just x over 3. All right, so factoring on the 5x squared minus 16x plus 3. Multiply to be 15, add to be negative 16. That's going to be negative 15 and negative 1. So GCF for the first group would be 5x. Second group, pull out a negative 1, leaving my other factors 5x minus 1 and x minus 3. The denominator, multiply to be negative 12, add to be 1. That'd be positive 4 and negative 3. So that's x plus 4 and x minus 3. So I'm just going to step backwards through all this and get through her. Said it was. It's a little on the slow side. Too many step backwards. There we go. All right, so there's my factored form. On the bottom of, all right, so when you flip this second one, I factored the 2x cubed plus 8x squared, and that's where I got the 2x squared x plus 4. Okay, that's the factoring of that 2x cubed plus 8x squared. And then the factoring of the 30x squared minus 6x, that's where I'm getting the 6x and the 5x minus 1. So I did the factoring as I did the keep change flip, just to save myself an extra step of writing. Now, vertically, diagonally cancel. So vertically, I got the x minus 3, canceling the x minus 3. I got the 5x minus 1, canceling the 5x minus 1. Diagonally, I got the x plus 4, canceling the x plus 4. If you're getting a little confused with everything being canceled out, I'm just going to go ahead and rewrite it out, 2x squared over 6x. That's the only thing left at this point. But I know that will simplify a little further because what is 2x squared? It's 2xx. And 6 is 2 times 3 times x, which is how we did it earlier. And then the 2 cancels the 2. This x cancels that x. That leaves an x and a 3. And that's how I'm getting x over 3, or 1x over 3, or however how you want to write that. X on the top and 3 on the bottom is the only thing left there. So a lot of stuff canceling on that one to make it work out. Makes it really, really nice. Okay. All right. So regular simplifying, factoring, simplify the fraction. When do you find domain again? The very beginning. Okay. Before you start simplifying stuff, get the denominator equal to 0. If it says something about domain, it happens first. Okay. So we did the regular simplifying, just one fraction, break it down. Then we did multiplication, diagonally, vertically, cancel, factor everything, cancel. Then we did division, okay? And then we got over to the last page of Lab 2, and that was the adding and subtracting section out of that. So the only thing that I don't like about Lab 2 is that it didn't give you any problems where you had a part of the denominator that was the same. Everything was always just relatively prime to one another. So let's look at example N here, and let's get a problem where we've got something that's similar in our denominators. So that's 3 over 5 plus 9 over 20. Okay, so looking at these two fractions and adding them together. So when I look at these two fractions, I look at the parts of them and I say, okay, well, do 5 and 20 have anything in common? Well, 5 goes into itself, and then it also goes into 20 how many times? 4 times. So 20 is really 5 times 4. That's really what that is. Okay? So these fractions have a 5 in common. Okay? So the first fraction has the 5, but it doesn't have what? The 4. So the first fraction needs a 4. So since I multiply the bottom by 4, I got to multiply the top by 4. The second fraction, it already had the 5 and the 4. It doesn't need anything. It's got everybody. So now I've got 12 over 20 plus 9 over 20, which is 21 over 20. And I've got a common denominator between the two, and I've added it together, and then I try to simplify if possible. 21 breaks down to 3 times 7, but 20 is 2 times 2 times 5, and nothing is in common between those two. So that is the simplified version of the answer there. So if you have something in common already, you don't have to put as much in there. Okay, that's kind of where we're going to be headed. So the donut example: 3 over 10x squared plus 2 over 15x squared. Okay, so throwing a letter in there because we got to get there. Looking at the denominators, what do I know about the number 10? It's 5 times 2, right? So I'm going to think about it like that. 5 times 2. 15 is 5 times 3, right? Now, both of them already had an x squared. So that's part of the common denominator. What else is part of the common denominator? The 5 that they share. What is different in the denominators? One's a 2, one's a 3. Okay? I can't make a 2 turn into a 3, but I can multiply both the first fraction by that 3. So I'm going to take that first fraction, and I'm going to have that 5 times 2 times x squared, and I'm going to multiply that thing by 3 so that it's got all of the same stuff. And then the second fraction, it's got the 5 and the 3 and the x squared, but it's missing the what from the first fraction? The 2. Okay? So I'm multiplying top and bottom by 2. Those are coming from, this 2 is coming from there. This 3 is coming from there. That's where they're coming from. Okay? So that's going to be 9 plus 4 on the tops of those. And then on the bottom, 5 times 2 times 3 would be 30. X squared. This is going to be 4 over 30 x squared. Common denominator. They got the same bottom part now. And that's going to be 13 over 30 x squared. 13's prime, and it doesn't go into 30, so we're going to leave it like that. Okay? Now, let's do this one. 3 over 7 minus 6 over 14x squared. So it looks a lot the same, but there's a major difference here. The x squared is not on both of them. It's only on one of them. So to be part of a common denominator, it's got to be on both of them, right? If I'm going to have a common denominator, it's got to have the same stuff on the bottom. So the first fraction is just got a 7. 7's prime. There's not anything else there. The 14 is really 7 times 2, right? What is the first fraction missing that the second fraction has in the bottom? A 2 and an x squared. So that first fraction, I'm going to multiply it by that 2 and the x squared. The second fraction, is it missing anything that the first fraction had? No, it's got the 7. It's not missing any pieces. So it's going to stay the same. 6 over 7 times 2x squared. We'll just write it like that. So that's going to be 6x squared over 14x squared minus 6 over 14x squared, which is going to equal, now, to be like terms, you got to have the same letters and exponents on the letters. So when you rewrite this, it's just going to be 6x squared minus 6 over 14x squared. That's how you're going to write that. Because they're not like terms, you can't take the 6 away from the x squared because the 6x squared has the x squared. So it's kind of like it's not a like term, it's opposite of a like term. So 6x squared minus 6 over 14. But there is a little bit of simplifying I can do on this one. What do all of those numbers in that problem, the 6x squared, the 6, and the 14 all have in common? They're all divisible by 2. So I could simplify this one more step by dividing everybody by 2. Okay, so that would be 3x squared minus 3 over 7x squared. So I could simplify my fraction just a touch, not much, but enough to say that there was something I should have done out of that. Okay, so denominators aren't the same. We got to make them the same. All right, so our first fraction is 7x plus 5 over x plus 4, x minus 5. So the denominator is already in factored form. It's x plus 4, x minus 5. The second fraction had 2x minus 4 on the top, and then it had x plus 4 and x minus 5 in the bottom. What do we know about the denominators? They're already the same. So I don't have to do any denominator work here. All I've got to do is put together the numerators. So this is going to be another one of those like term deals. Okay? So when I put those together, I got 7x plus 5 plus 2x minus 4 over x plus 4, x minus 5. I'm going to put like terms together. What are the like terms on the top? Yeah, they are like terms because they got the same letter and same exponent on that letter. So that's going to be 9x. And then 5x plus negative 4 is, it'd be plus 1, yeah. And then we have x plus 4, x minus 5. The last thing that I have to do is check to see if the numerator could be factored and get something to cancel out. Will 9x plus 1, will it factor with a GCF or anything? 9 and 1 don't have anything in common. There's not an x squared on it, so I can't do like x method or anything like that. So no, it won't factor any further. That is the simplified form of that. Because I already had the like denominators, I just put like terms together in the top. Okay? So that one already had like denominators. Guess what the next one? It ain't. Okay? So let's get one that doesn't have the same denominator. So let's say we had let's say we had 5 over x plus 4. We'll do plus again. And let's say we had 3x minus 7 over x squared minus 16. Okay, so kind of going to add a little bit of factoring involved in this one. Okay, so on this problem, the denominators are obviously not the same. One's an x plus 4, the other one is not an x plus 4. So they are not the same. So in order to be able to add these two together, I need to get the denominators to be the same. So the first thing that I need to do is find out what are the components or what are the pieces of the x squared minus 16. So the pieces that make that up are the factors of that. So let's factor x squared minus 16. What does that factor as? Yeah, x plus 4, x minus 4. All right, so now we look at the denominators and we see that the first fraction has an x plus 4, the second fraction has an x plus 4 and an x minus 4. So they share something. What is the first fraction? What's it missing that the second fraction has? It needs that guy. It needs the x minus 4 to be the same. So when I go to do this, I'm going to take that 5 and I'm going to multiply it by x minus 4. And the bottom part, I'm going to take that x plus 4 and I'm going to multiply it by x minus 4 because it was the part that was missing. The second fraction, it already has both of those, so I'm not going to change it. I'm just going to rewrite it as x plus 4 and x minus 4. Now, denominator stays the same, so that's x plus 4, x minus 4. The numerator, what do I do with the 5 and that x minus 4? Yeah, it's distributed property. So I'm going to say 5 times x minus 5 times 4. So that'd be 5x minus 20 plus 3x minus 7. So 5x minus 20 plus 3x minus 7. I'm writing out every single step here. You obviously can do steps in all at once there. I actually advise you to do that just because you can. And now we're going to put like terms together. 5x plus 3x is 8x. Negative 20 and negative 7, negative 27. And then I have x plus 4, x minus 4 on the bottom. Will x minus 27, will it factor? Eight and 27, do they have anything in common? No. There's not an x squared on there, so I can't do any like difference of squares or cubes or anything like that. So that is all that I can do on that one. Okay. All right, one more for this section, and then we'll take a break, and then we'll come back and do the last section, okay? And that way, like I said, the second section is a lot shorter than this one. This is a pretty heavy section. All right, so here's our problem. 7 over x squared plus 4x minus 5 minus 10 over x squared minus 25. So a subtraction problem, and the denominators are not the same. A little bit of everything in this one. If the denominators are not the same or are not factored yet, my first job is to factor them. So factor this one, the left one. Multiply to be -5, add to be 4. 5, -1. So x plus 5, x minus 1. And I usually just write that underneath it because that's really kind of the in-between step. I'm not doing anything with it yet, but I'm going to. And then how does x squared minus 25 factor? Yeah, that good old difference of squares, that's a very common thing for them to give you. Is that? So now, what do they have that is the same? X plus 5. Okay? So the part that's the same is the x plus 5. So neither of them need that. The first fraction has the x plus 5, but it does not have the x minus 5 that the second guy does. So we need to share that with the first fraction. So when I go to multiply, I'm going to take 7 times x minus 5. And then on the bottom, I've got the x plus 5. I've got the x minus 1. And then I have the x minus 5 that I'm multiplying times that thing. And that's coming from the part that was not shared or was not in fraction, the first fraction, but it was in the second fraction. Okay? Now, what does the second fraction need? It needs an x minus 1. So minus 10 times x minus 1 over x plus 5, x minus 5, x minus 1. And that x minus 1 is the part that the first fraction had that the second fraction did not. Okay? And now let's put that together with the subtraction. Okay? So that's going to be, whoops, give me a pen instead of the highlighter. So that's going to be 7x minus 35. Then what? What does this? It'd be negative 10x, not minus 10, but plus 10. Why is it plus 10? When I distribute, I've got to distribute this sign with that 10. Yeah, you treat it as a negative 10 times x and a negative 10 times negative 1. That's how you want to deal with that. The subtraction problems, that is one of the things that's most commonly missed, is that minus sign not being distributed. Okay. And then on the bottom, I've got that x plus 5, x minus 5, x minus 1. It doesn't matter what order you write those in. Your favorite order is absolutely fine. And then put those together, like terms. What is the numerator going to be? Negative 3x minus 25 over x plus 5, x minus 5, x minus 1. Boom. And that top part doesn't factor any. That would help. So leave it like that. Okay. Whew. A lot of stuff. Factoring is the key, though, and getting when you're adding, subtracting, you got to have like denominators. When you're multiplying, dividing, just factor. You don't have to have the denominator the same. Okay. So suggested problems, if you're using the textbook in R5 1 through 77, the odds would be a good place to do a few problems there. Do the ones you need more practice with. I would say addition and subtraction is the one that you need it most with. Yes, ma'am. Oh, I did on the red part. Yeah, thank you. Should be a minus there. Thank you very much. There we go. Better. Sorry about that. So let's take a quick break, go to the restroom, splash some water